And so we will continue with Chapter 1, ITT 340, Introduction to Mainframe Operations. This is Part 3 of Chapter 1. And we'll move a little more quickly now because we were in some fairly dense material early on, so we'll try to make a little more progress. Mainframes in our midst. So we'll talk a little bit about the prevalence of this technology, where it's seen, etc. You all use mainframes, you just don't realize you do. If you have a bank, if you make a phone call on a cell phone, if you buy a plane ticket, you just probably use a mainframe at least 5 or 10 times every day. You just don't realize you're doing it. And a lot of the data, it used to be 70%. That's down a little bit now because there is a movement kind of to distributed systems, but the estimate of the amount of data in the world on mainframes is between 60 and 70% of the world's data sits on a mainframe. So they're prevalent, but you don't see them, not publicized. They're different from other forms of computing like PCs or smartphones, etc. But they have a lot of opportunities for college students like yourselves in terms of very, very well paying employment. So what is a mainframe? Well, basically in this class, this class purposes, mainframe is a system that handles a lot of users and processes a lot of jobs, essentially. But you can go through the slide here to see kind of how IBM's take on it. But it's a computer that does a lot of work, essentially. And for the most part, businesses use them, but also a lot of public agencies use them too. State of North Carolina is a very big mainframe user. So what are the facts? And this has a little data on it, but I'll try to get some updated data. But pretty sure that 60% of all data available on the internet is stored on the mainframe. Pretty sure about that. And actually that number may be up because I do see a movement, as I said, away from the platform, but in another sense it's going back there because a lot of workloads are being moved from the distributed processing world to Linux on a mainframe. So companies that are using Linux see that you can use Linux a lot cheaper on a mainframe. Total cost of ownership, and that gets a little complicated, but we'll talk about that. So why do we use them? Large-scale transaction processing. We don't know of another technology that can process. Right now it's up to 100,000 transactions per second. 100,000 transactions per second. Securely, accurately. We don't know of another technology that can do that, and there is a big need for that by a lot of companies. You can support thousands of users, tens of thousands of users actually. They can be on the system simultaneously. Terabytes, now petabytes of information in databases, and large bandwidth communications. This is still true. There are more CICS transactions. Again, CICS is a transaction processing system than web pages served, and that is still true today. So factors for the mainframe. RAS is important, so this is something I'll try to, as the lectures go on, I'll try to note pieces that are going to be that I'm sure are going to be on test. RAS is one of them. Reliability, availability, and serviceability / scalability. So if you don't put serviceability, put scalability, I'm fine. But RAS is an acronym for you to remember. Security, scalability, centralized control, workload management, partitioning, virtualization, continuing compatibility, evolving architecture, application enablement, complexity, variety, thousands of users, etc. Now, Z9, this definitely says the age of these slides. The current technology now is a BC12, EC12 actually, Enterprise Computer 12, much more robust system than this Z9, but I'll get you some updated slides so you can see. Now, some of the interesting facts about it, and this is what we have. We have a Z9 Enterprise class at A&T. So it's a couple of steps back, but it still works, and it works well. A couple of things. 60 partitions. This is important. That'll make sense to you as time goes on. Another one over here. FICON is a fiber-based connectivity networking. It's hypersockets. We'll talk about what hypersockets are. OSA cards, Open Systems Adapter. OSA stands for Open Systems Adapter. That is the connection device on a mainframe. It's actually a processor, and we'll talk about that also. And this is under the hood, so we definitely will have a tour of the data center for you to go see a Z9 up close. So you'll see everything here. You'll see over here the service elements. You'll learn what a service element is. You'll see what the books are. They contain the processors and memory, etc. And these are the OSA cards for the I/O input output. This is just fascinating stuff. Won't talk about books too much because I never take my books out, because you can slide these out. I don't have the guts to do it, so we'll talk about them, but we're not gonna actually pull them out. That's not wise. They're very heavy. The chip, very sophisticated chip. We'll talk a little bit more about the chip later. It does a lot of things. This is not an architecture class, so we're not going to talk about the chip a lot. So I think we can skip this slide. It's a little too dense for our purposes. And again, yeah, let's talk about this a moment. Matter of fact, let's pause here. Let you go play basketball or go on a date or whatever, and come back on the next slide. I want to start with this slide so we can talk about these processors. So be well until we meet again, class.